Welcome everybody. In this video, we're going to talk about adding rational expressions without common denominators. So now we're doing it with unlike denominators. So now we're asked to add these two expressions together. First thing we always got to check, just like we do with fractions, are the denominators the same? Well, they're not, and that's the whole purpose of this. So what we need to do is find our least common denominator first. The way we're going to do this is we are going to factor both denominators. So I'm going to take this first one and I'm going to create two binomial expressions and I'm going to factor this out. So I know x goes in the front here. That's how we get x squared. Two numbers that multiply together to give us positive 4, but when we add them, give us positive 4. Well, we know that's just 2 and 2, and so that is factored. Factoring this one on the right, again, breaking it into two binomials. What are two numbers? Well, I should start at the beginning. We'll put the x's in the front. And two numbers that multiply together to give us positive 2, but when we add them, give us positive 3. Well, that's just pretty simple. Going to be positive 2 and positive 1. So here we have them factored, but now we need to find our least common denominator. So remember, we're going to multiply together all the unique factors together. This can be simplified as x plus 2 squared. And so when we have the same factor between the two, we are going to use the one that has the bigger exponent. So our LCD is going to be this x plus 2 squared times this factor over here, x plus 1. All right, that way we've got them all represented, and here is our least common denominator. So if we were to rewrite this entire addition problem and rewrite these two expressions with our least common denominator, we know they're both going to be now x plus 2 squared times x plus 1 plus x plus 2 squared times x plus 1. Here's our least common denominator. So now that we have a least common denominator, we have to change the numerators to reflect the changes we made in the denominator. Remember, we want to keep these rational expressions equivalent to one another, so whatever we do to the bottom, we have to do to the top. Well, if you can see, our original denominator here was x plus 2 times x plus 2. Well, what did we add to it? We added x plus 1. We multiplied x plus 1 on the bottom, so we have to do the same to the top. So it's going to be 8x times x plus 1. Over on this right-hand side, our original denominator is x plus 2 times x plus 1. Well, what did we add in? We added in another x plus 2. So we have to multiply the top by that as well. So it's going to be 5 times x plus 2. From here, we can just go ahead and add our numerators. Our denominators will stay the same. So we're going to have, and if I multiply this in here, and multiply this in here, we're going to do 8x times x, which is 8x squared. 8x times 1 is plus 8x. Then we're going to add to it 5x plus 5x times, 5 times 2, which is 10. And that's over our common denominator, which stays the same, x plus 2 squared times x plus 1. From here, we're going to go ahead and simplify our common terms. So there are no x squared terms, so we will leave it as 8x squared. 8x and 5x gives us 13x, and then we have positive 10. And that is over our common denominator of x plus 2 squared over x plus 1. And that is our final answer after we add these rational expressions without common denominators.